Hey, in this one I wanted to show you what ZeroMQ messages are, which we've been using them all along, but kind of hidden. So you can see I took back the example from the first video where I have a publisher and a subscriber. You can see the publisher is running in the background, publishing messages, and we can subscribe to it. Nothing new. So now I will show you what a message is. So ZeroMQ has this ZeroMQ message T struct, which allows you to basically create a message. You can initialize it with ZeroMQ message init, where you pass the address of the message. And now, instead of receiving in a buffer, you can simply call ZeroMQ message receive with the message, the socket, and the flags. And now it will have received all the data inside of this message struct. And so, well, the first advantage that you can see is that it will compute the size for you. So now if well, that might be a disadvantage since I didn't include the null pointer. Let's modify the publisher quickly. Oh no, I did include it, 6 bytes. Never mind. So what we can do now is we can access the data that is inside of the message with ZeroMQ message data, like so. And we need to cast this to a string. And of course, since we allocated something, we need to close it after we are done using it, like so. So let's try to run that. So, and we can see we have the exact same behavior. And also you can retrieve the size of a message with, well, you probably guessed it, with ZeroMQ message size, like so. Yep. That's a warning. Maybe, yeah, just because of the printf. So you can see, it already knows the size of the payload. So this is on the subscriber end. Let me show you a bit more examples on the publisher end, where we can also put the message inside of a message. put the hello payload inside of a message. And to do this, we do need, since we're sending it, well, the send doesn't know the size of the payload, so we do need to tell ZeroMQ what the size of the payload will be, and this is with ZeroMQ message init size. What a mouthful. We want the message to be able to contain 6 bytes, and we can just copy into ZeroMQ message data message, like so. We want to copy hello with a size of 6, like so. This doesn't change, and yeah, did I mention it? You do need to close the message once you're done using it, just like most things in C. So ZeroMQ message close, and here we can do ZeroMQ message send, like so, and this will take our message up, like so. And I think we can, yeah, we can still, no, that was a modification on the publisher. And so, yeah, see, it still works as before, but now we are manipulating the message directly. Of course, this is a bit inconvenient, so there is a thing called message init buffer, which allows you to, well, pass the buffer directly, like so. But you do need this ZeroMQ build draft API to be able to use that, because it's not like a super stable feature. But we'll be able to see that, well, it's the publisher once again. But it should be exactly the same. So yeah, that's a little shortcut. You can also, yeah, now this is a more important part. So now that you have message, I've shown you we can achieve the exact same behavior as before with messages, but it's not really obvious why you would want to use them. And one of the nice features of messages, let me run the subscriber in the background instead. is that you can separate them in multiple messages that will be sent together. So this is called like multipart messages. And basically what you do is that, let's say you have message 1 here, like so, and let's put this at the top. And so we have message 1, we have message 2, and let's initiate both of them. So Charles, payload 8, and we can send actually both of them. And if you would send them like this, it would, well, first send message 1 and then send message 2. And from the receiving end, there would be like two distinct messages. But what you can do is kind of group them together with the flag ZeroMQ send more, which will say that, which will include some metadata in the first message saying that there is another message following it. So now from the receiving end, you will have to be able to handle two messages. So let's just do that. And on the subscriber, now we need to modify our code. So to check if there is another message after the message you've just received, you can use ZeroMQ message more, because it will have more flag. And if it has more data, well, we can do exactly the same as before, but let's call it message 2, like so. And message 2. So now we are able to handle a second message. We do need to close that one as well. Up. And I think we're all set. So let's compile that again. Let's run the publisher here. And so you can see that now the publisher is sending two messages on every loop iteration. And from the subscriber point of view, it can receive both messages. And so how is this useful is that, like, when your data gets more complex over time, you usually want to separate it into distinct chunks. And so that's how you can do this. Or if you have like let's say a variable amount of data, and like you have a struct and you have an array, like a variable array of these structs, and you can have like between, I don't know, like 1 element and 500, and maybe you want to organize those in every single one in one message. So yeah, and when you group messages like this, they are guaranteed to be sent together. So this first send won't like do a TCP send. It will just keep the message in memory since you've specified the send more flag, and it will wait for the next message. And as long as they have the send more flag, it will combine them in memory, and as soon as there is the 0 flag, it will send all of them at once. So yeah, it's just a nice way of organizing your message. By the way, the subscriber that I showed you in a previous episode only checks for the prefix in the first message, not in the second one. So, well, actually, I can show you this. If I subscribe to hello C, like so, well, let's just subscribe to hello first, like this, and we should be able to do this. So yeah, this still works, but if I subscribe to hello C, like so, well, it would be hello, a null thing, and then C, so 7. If we subscribe to that, we see nothing happens because it can only match on the first message frame. So let's remove all that. Oops. So this was for the multipart messages. There is other cool stuff, but I'm just looking at my notes. I think let's remove the more example because it gets a bit confusing otherwise. All of these can go away. So one cool thing as well is that now there is a multiple functions to try to avoid copying, which is kind of neat. And actually, I realized that I made a blunder because I do want to keep this. So the first function is ZeroMQ message copy, where the first argument is the destination and the second is the source. So this acts like your regular copy. It will copy, in this case, message 1 into message 2. Message 2 does need to be initialized first, so. And then let's only send a message 2 like so. And in the subscriber, let's only receive one. That seems fine. This is the subscriber, and let's run the publisher. And I think this should work. Yeah, it does. And this might seem silly at first, because why would you need that? But actually, under the hood, like, the message sometimes has a reference counter to it, and so it's possible that calling ZeroMQ message copy actually doesn't copy the thing sometimes. Like, if possible, it won't, which is kind of a neat optimization. This is quite nice when you need to feed the data from like one socket into another one, but you need some kind of processing step in between, but you don't really want to recreate the message completely, or you want to try to avoid copies. This might be a good thing. But actually, the next function I'm going to show you actually makes sure that there is no copy. So there is ZeroMQ message move, which, well, in this case, it will completely reset message 1 and move all of its content into message 2. So message 2 takes ownership of whatever message 1 has had. Again, this should just work like so. Well, you can't really see it, but still receiving hello, but this time there was maybe less copies, you know. And finally, the last function, which maybe I should have started with, because it's probably the most interesting one, at least to me, is that, so maybe let me reduce my example. Let me do something like removing message 2 everywhere, and we send message 1. Let's kill this. So there is an issue here. So, well, of course, there is no issue, but like, let's say we would have a very large amount of data, or like our messages would be like, I don't know, multiple kilobytes, and we had a lot of them. Basically, a large volume of data. When you have a large volume of data, you want to avoid copies at all costs. And so here what happens with this message init buffer is that there is this pointer to a buffer and the size, and what ZeroMQ will do is that since it needs, well, to handle the message in various ways, it needs to copy the buffer, basically. So it will do a copy of whatever memory you gave him, and we can avoid that. So let's say that my payload, well, let's call it payload, is something that I allocate myself, like so. I can actually call the message init data, which now can take a pointer to something that was allocated by you. And then it takes a size of this, so this is still 6. Then it will take a free function. So what will happen is that you're kind of transferring ownership of the memory you allocated to ZeroMQ. You're giving it a function to free the stuff you allocated. And then, yeah, you just give ownership to a ZeroMQ, and when ZeroMQ is done with it, like sending it over the network or whatever, it will call your free function on the data. So let's create a little free wrapper, and the free function can also take an argument, which we won't use now. Free wrapper void data void hints, like so, and this will just free the data. Nothing fancy. And this way we've avoided like one copy, since, well, this is allocated once, well, this is copied in the str.dub technically, but well, we've done one allocation, initialized our data here, and then we passed it to ZeroMQ. And of course, I wouldn't Since ZeroMQ has the ownership of it, you cannot use it after, otherwise it will create issues. So let's just try this. This is still the publisher, so let's try to do this. And as you can see, we still receive the good old hello. But this time with less copies, which is much better. And so yeah, I think that's about all I had to say about the messages. Yeah, that last one especially I find cool when you're like passing around messages between threads, and it's like a pure C or C++ struct, and you can just allocate it on the heap and avoid copies by using a message init data, which is kind of cool if you have like a large volume of data which you need to pass around quickly, and you want to avoid copies as much as possible. That's quite neat. Anyway, that's all I've got, and yeah, the messages will come more and more handy as we go through this series of videos. So yeah, you should get familiar with them. Anyway, see you in the next one.